And so now C is, which is the rate determining step? That was pretty easy. And like I say, you know that because 2 is the what step? The slowest step, the one with the highest activation energy. Okay. So, D, what is the catalyst? M. And then E. So we've already covered most of it. All of the problems we've done so far, A through D, probably would be about 5 points each. E is going to be probably about 15 points. Okay? So we've got 20 points already. And now the next one's a 15-point question because you have to have several features that I'm going to be looking for. Okay? And the first feature I'm going to be looking for is, first you have to write the rate law. What tells me the rate law? The slowest step. And since these are elementary reactions, you can write the rate law directly. And the rate is going to be equal to K2 times the concentration of A of the intermediate species. Okay? And that's 5 points right there for just catching that. That's a main feature. Slowest step. You should be able to write the rate law directly from it. Now, having done that, I have to deal with the fact that this is an intermediate species. It's not something that I can control. So we have to re-express this in terms of things that we can control, because we can only observe what we can control. The things that we could change the concentration of. So I want to take advantage of the first step being a fast equilibrium step. And for all equilibrium, what is always true? What's true of all equilibrium processes and when it comes to rates?
K1 equals K1.
Well, the forward rate equals the reverse rate. That's why they're equilibrium. There's no further change. And so I can express that mathematically as K1 times A B3X times the concentration of M is equal to K minus 1 times AB 3MX. And now I'm going to record up just a little bit. Okay. There's another 5 points. Okay. Now what I want to do is I'm going to, well, not quite. This is half of another 5 points. I want to solve that for the concentration of the intermediate species. And so I rearrange that and I write that A, B, 3, and the concentration of the intermediate species is equal to K1 divided by K minus 1 times A, B, 3X times M. Okay, so this is another 5 points. And now all I have to do is substitute this in the above expression for the rate law. So all of this stuff here, because of this equality, I can now substitute in, and I end up with the final answer that rate is equal to K2, little K2, ratio of the rate constants times and I'm pretty much done, aren't I? So that would be, I just substituted this in for the intermediate species. Now, if I want to get fancy, if you have this, you got 15 points. 5 points for this, 5 points for this, 5 points for that. Those are the 3 features I'm really looking for. And now, if you want to get fancy, it's not going to give you any extra points, but it might make you feel better because you can show off and feel free to, you know, what is this ratio of rate constants equal to?
Big K.
Big K. So I could continue out here and go, this is equal to K2 times big K1, because now this is not a rate constant. What is it? It's a mass action constant. So it's an equilibrium constant. And then substitute that in, and A, B, 3, X times the concentration of M. But wait, there's more. I'll throw in a free can of Ari and a chamois with every purchase. What's the next thing I could do if I really want to get fancy schmancy?
K observed?
Yes. Actually, what we have, see, in order to tether this to what we've observed in the laboratory, recognize that this collection of terms before the concentrations is the observed rate constant that we would observe in the laboratory. And so I can say this is equal to K OBS times A B 3X times M. And like I said, the part in green and red, that's gravy. You don't have to put that in there. I want at the very least this. Is this much clear to everyone? Yes?
Can we substitute for the last step, can we just do big K1 instead of?
Yes, you know, in other words, could you put this in here?
Instead, yeah.
Yes.
And that would be fine.
That would be okay. I will accept this, I will accept this.
Why does big K drop
Either
out?
or.
Where did big K comes in? We introduced it because big K,
Why does it drop out in red?
because
K2 times big K.
for the
minus
following,
K
this is K observed. We just substituted that in for little K2 times K1. It is going to be that collection of rate constants, because this is just a collection of rate constants. But we might necessarily not be able to observe and measure, but we are able to observe and measure this. Okay? Is that good for the first part, A through E? So now, shall we find another board and do part F? Yes.
What's that for?